Alright, let's jump into the solving radical equations notes. I'm going to quickly run through these couple warm-ups. You can try them first if you want, and then use my work as an enter key. So on number 1, I have 6 to the 1/2 raised to the 6th power. Well, I know when I multiply when I'm raising a power to a power, I want to multiply exponents. So this is really the same as 6 to the 3rd power, which is the same as 216. Next we have the square root of 4x to the 4th divided by the cubed root of negative x cubed. Well, I'm going to treat these separate. I know that the square root of 4 is 2, and the square root of x to the 4th is x squared. In the denominator, I know that a cube root asks me what number times itself 3 times equals the number inside the radical. Well, negative x times itself 3 times is negative x cubed, so that is the simplified form. So my final answer here, I just want to simplify my fraction. It will be negative 2x. Here I have a quadratic function. I can solve this any way I like. Here I have no b value, no linear term. So I'm going to add 17 to both sides and get 2x squared equals 18. Divide both sides by 2. X squared equals 9. So x must equal plus or minus 3. Number 4 here. Well, we haven't really seen something like this before, but we can kind of use what we know. Well, we know that first thing I want to do is isolate that square root. So I get the square root of x equals 13. Well, if I want to unsquare root something, it's really like I square both sides. So in this case, x must equal 13 squared. Which is 169. So that's the warm-up. That last bit there is really the key idea we're going to be using in this lesson. We are going to solve radical equations. So our steps here, we're going to get the radical isolated. We want to get the radical by itself. We're going to raise both sides of the equation to the power of the index of the radical, and then we're going to simplify and solve. I'm going to walk through a couple examples and show you what I mean by that. So example A here, I have 2 times the square root of x plus 1 equals 14. First I want to isolate the radical, so I divide both sides by 2. I have the square root of x plus 1 equals 7. Now I need to get rid of that square root, so I'm going to square both sides. When I square both sides, I get x plus 1 equals 49. So x must equal 48. And I'm done. So let's try another one here. Let's move over to example B. Well, here I have a rational exponent. That shouldn't throw us off. We can treat that as if it were a radical. So first I want to isolate that radical. I'm going to divide both sides by 5. And I'm going to get 4x, sorry about that, plus 3 to the 1/3 equals 3. Now if I want to get rid of this exponent, I'm going to raise it both sides to the 3rd power. Why does that work? Well, when I multiply these exponents, 1/3 and 3, the result I get is an exponent to the 1st power. So what that does, it really gets rid of our rational exponent. So I will have 4x plus 3 with no exponents equals 3 to the 3rd, or 27. Now I just have a linear function I need to solve. I subtract 3, so 4x equals 24. Divide by 4, x equals 6. Let's keep moving here. Let's look at part C. So here's something interesting. What I need to be careful of is this too. Now, if I wanted to, I could divide both sides by the cubed root of x minus 1. That might make things a little bit more complicated. We'll have a fraction. We'll have to worry about some more complicated things. But what I notice here is that I have a cubed root on the left side of my equation and a cubed root on the right side of my equation. So what I'm going to do is I'm going to cube both sides of the equation. The left-hand side, it should look pretty straightforward. When I cube both sides, I get x plus 6. Why does that work? Cubing a cubed root, well, they just undo one another. Over here on the right, we need to be very careful. Now, this cube needs to go to every member inside the parentheses. So I need to take 2 cubed, which is going to be 8, and multiply it by x minus 1. This is probably the key thing that gets overlooked most often in this unit. When I cube something with a coefficient, like this 2 here, I need to cube that as well as what I see inside the radical. All right, let's go ahead and finish this problem up. I have x plus 6. Let's distribute that 8 equals 8x minus 8. So that means that 14 equals 7x, and that 2 must equal x. So let's move to the example on the next page. So in this example, Alicia solved the radical equation and got 2 solutions, and Jimmy solved and said there's only 1 solution. So what we want to go ahead and do is let's just try to solve this equation and see who's right. So what we have is the square. Oh, sorry about that. We have the square root of negative 3x plus 33 equals 5 minus x. I want to isolate my radical first. It looks like it already is. So now I'm going to square both sides. When I square this here, I'm going to get negative 3x plus 33. And when I square this, now here's where I have to be careful. This is going to be a quadratic. I'm going to get 25 minus 10x plus x squared. So this is a quadratic. We'll have to solve this. I'm going to set the whole thing equal to 0. I'm going to move everything to the left-hand side. And once everything gets settled, I'll get x squared minus 7x minus 8 equals 0. So now I'm going to factor to solve this. I'm going to get x minus 8 times x plus 1 equals 0. So my 2 possible solutions are 8 and negative 1. Now, if we read carefully, that shouldn't come as a surprise to us. That's what we saw, that when Alicia worked this problem out, those were her 2 solutions. Just like in our rational equations, when we had to check our answers to make sure that our solutions were legitimate, we have to do that with radical equations as well. So the way I do that is I go ahead and take 8 and negative 1 and plug them into the original problem. So let's test at 8 here. So what that would look like, it would be the square root of negative 3 times 8 plus 33 equals 5 minus 8. Well, if we simplify this radical, I get negative 24 plus 33. That's going to be the square root of 9 equals 5 minus 8. So I get this statement here. 3 does not equal negative 3. That means that 8 must not be an answer. Only negative 1 is a legitimate answer. So for the you try on the bottom of this page, I'm going to ask you guys to go ahead and try it. If you wait about 5 seconds, I'm going to pause this, work out all the answers, and you'll have this answer key right in the video. Thanks. And here are your solutions. For number 1, I cubed both sides and got x equals 4 once I simplified. For number 2, I divided by 6 first, squared both sides, and got x equals 39. For number 3, I squared both sides, being careful to square the 3 as well, found that x equals 6. For number 4, I squared both sides, solved the quadratic, and found that my two potential solutions were -5 and 1. But when I tested -5, it was extraneous, meaning 1 is the only legitimate answer. On number 5, I cubed both sides and simplified. Don't be scared of a fraction answer. I ended up with 16 over 27. And finally, on number 6, I subtracted 4 from both sides, raised both sides to the 4th power, and found that x equals 2. All right, you can move on to the next section of this lesson.